Alright, YouTubers, welcome to my shop here in Asheville, North Carolina. This is my 4-cylinder solenoid engine. The coils are 24 volt coils, but I'm running it on a 12 volt system. And what's nice about that is the coils can run all day and not even hardly get warm. They basically stay at room temperature. Let's see, the beer can is for a size reference. I'm powering this with a battery charger mainly, and the battery charger doesn't put out quite enough current, so if I really want to run it fast, I hook it straight up to a car battery and it gets all the current that it likes and it runs great. I have the charger hooked up to this plug-in neon dimmer switch, and that allows me to control the voltage that's going into the charger. And I probably wouldn't do this with a digital charger, but this old analog charger has no problems running on a dimmer switch. Let's see. This project started with a friend, an electrician friend of mine. He gave me all this copper bus. He harvested it from a hospital, and some of this bus was a 1/2 inch thick. That's a 1/2 inch thick bus there that I cut. Here's some smaller 1 inch wide by, I believe, 1/4 inch thick bus, solid copper. That's I believe 5/16, and it's like 4 inches wide. But anyways, he gave me all this bus, and I started making this engine. I originally had some smaller coils, and through research, I learned a few things about solenoids. Surprisingly, if you do your research, that's what happens. You learn something. So I discovered that for an engine, I wanted a long stroke engine. This engine is a 1.25 inch stroke. So I have a 5/8 throw on my crank, and that requires a longer coil. So the longer the coil is, obviously the longer the stroke can be. There's a point in a coil when you put the slug in that the slug rests. It's going to find its home and it rests there. And so what I wanted in this engine, and the way I designed it, is that at bottom dead center, that slug is not at its home yet. So it's trying to get home at bottom dead center, but I shut it off and then it goes back to top dead center. And the reason you do that is you're trying to extract as much power out of that slug, right? So if the slug finds its home, there's no power there. You want to extract the power of the slug trying to find its way home. So anyways, that's something to think about if you're designing a solenoid engine. I had to make the slugs. I got these coils from the metal recycle. They had a big pile of them, so I grabbed about a dozen. And I took them home, and through research and such, I was able to discover that these are 24 volt coils. They didn't have slugs with them, so I had to make my own slugs. And these are just soft steel. It was 1 inch stock, and I think these are 7/8 slugs. The bore is a 1 inch bore, so these are slightly smaller. And the flywheel came from the metal recycle. It was all mangled, and that's probably why they threw it out. It's a gear blank is what it is. It was in a pile of gears. This one was not cut yet, but it had it looked like it came out of a machine crooked. So the face of it was crooked. It had a waffle to it. So I take that out on my lathe and cleaned it up so it spins nice and true. Let's see, I poured and cut these gears out of aluminum, the tiny gears. My cam, it is a 3/8 rod got these little cam lobes on there. And the lifters, I'll show you the lifters. These are, I believe, 3/8 bolts or 1/2 inch bolts. I can't remember. And of course I cut them off. I machined the bottom and put a little divot in there for the rod to sit in. And something I learned about these lifters. So originally I machined the bottom of the lifter flat. And what happened is it made a lot of resistance. It was surprisingly really stiff. Even with oil on it, it was like a little break, and it was breaking the cam. So through a little bit of research, I discovered it's important to have your lifters spin. It's a lot easier to lift something if it's turning. And I put these actually on a little tilt. So the lifter is coming up, and the lobe is pushing on the edge of the lifter, and it causes it to spin, and it magically took away almost all the resistance in that, in the cam lobes and lifters. So it acts like its own bearing as it's spinning. It's just much easier to lift that rod. I got my little brass rockers here I made. I didn't really shape them yet. I just started with a square piece of stock, and these are my oil holes and a little dribble of oil on the push rod, and the rocker pin gets some oil. So for my contacts, from, once again, my electrician friend, he got me a bunch of this weird alien material. It's like from the 40s or 50s, probably made of asbestos and lead. Anyways, it's insulator. And so I was able to cut some down and whittle it, and you know, of course I wore a mask. But anyways, so I have this a little bolt in here with a nut on it, and it's a brass bolt, and it's soldered to this wire. This wire is one side of the coil. The other side of the coil is attached to this bus bar, which is just a piece of wire to bring my 12 volt positive in, and it's insulated from everything else. So the coil, one leg of the coil is on that positive bus bar. The other leg comes out and goes to this bolt right here, and as the rocker rocks, it grounds out the coil and makes the connection. Now, something else about coils. Backwards electromotive force. So originally I had these going, but these are really high current coils. They suck a lot of current. They can take, my charger throws out 4 amps, and it maxes that charger out. So I'm, you know, it just pegs the needle over, so I don't know how much actual amperage is flowing in here. I do have an amp meter, and I'll hook that up here and figure that out one day. Point being, with the high current, when these switches open up, it throws a hard spark, and it was burning out my contacts. And I have these adjustable. Got the little lock nut there, so I can unlock it and take that down a little more to adjust the contact and when it makes its contact. Anyways, that spark was burning these out really bad, fast. And so through research, I was able to discover this thing called Flyback diodes. And so what I did is I put some diodes on there. I ordered these on eBay. These are 1,000 volt, I think 10 amps, which is a lot for these little diodes. Here's what they look like. So I got like 20 of these for, I don't know, $5 or $6. Anyways, that took away the spark issue. There's no spark happening. What it does is it doesn't remove the flyback electromotive force, but what it does is it just gives it a place to go. It sends it back into the source. So what happens is when a coil, when that contact opens, that's when the coil throws a spark. All right, just like in an automotive coil, it's the same way. A lot of people think that it throws the spark when it makes a contact. That's not how that works in an automotive coil or in any coil. It's when you break the contact open that the spark is thrown. And it's because the magnetic field in the coil collapses at the speed of light and it generates a spark. Anyways, the flyback diode fixes that issue. And that flyback diode does not have to be a high voltage diode. It has to handle the current that your coils handle. Because that's what it's doing. It's taking the power from the coils and rerouting it back into the source, as opposed to it's not trying to shut off that high voltage spike. It's shutting off the current that causes the high voltage spike. So anyways, just a little lesson on solenoids if you don't know that. So my LEDs on here, I wanted LEDs on this engine. So on this back flywheel, I have some magnets attached to the wheel. There it goes. There's an LED in there. I have a little tiny coil. This coil came out of a relay, which is essentially another solenoid, but it was a nice little tiny coil, and it just so happened to power these LEDs perfectly. It's just putting out like 1 or 2 volts, you know what I mean? I put an LED in here. This is a cigar tube, a glass cigar tube, Sierra, Vega, whatever, cigar. And I put some little brass fittings on here and such, and put an LED in there, and I thought that was a nice little touch to it, to have that LED lighting through there. There goes my clock. My crank rods, they are aluminum. Handmade those out of some, I believe it was 3/4 inch stock, like plate, and I cut them out on the bandsaw and whittled them out, and then put them on the lathe and did the bore. And this mechanism here that you're looking at, it's probably hard to see with everything in the way, but what's going on in here is there's a skateboard bearing on a track. It's similar to the cross slide on a steam engine, but instead of a slide, I have a skateboard bearing, and that's what keeps the slug straight in the hull. As that rotates, let me see if you can get a look at that. There's a yoke. That con rod goes into that yoke, and there's a pin that connects the 3 parts together. And of course, everything's covered in oil. I've been running the heck out of this thing. I just run it all day long. And sometimes I'll throw it on the battery and just let it run full blast for an hour or so. And it just runs great all day long with no problems. I love this engine. Kind of proud of it. It turns really nice. This crank is on electric motor bearings. They are roller bearings. The cam is on skateboard bearings. And I like roller bearings. It really makes things roll nice. So anywho, hope you like my engine. If not, that's okay too. It don't matter. I love it. I think it's cool and it sounds awesome. I just love listening to it. It sounds like a tractor engine. And I'll read a book or something and just put that on, and it's kind of like my radio. So anywho, thanks for watching.